Okay, today is combinations day 2, and I'm going to call it CC over C because yesterday we did this also, but yesterday's problems really didn't even need the denominator. Today's always, we're going to do something like this. A combination being multiplied on top with other combinations, and these are the subgroups. Like this big group of 52 cards is divided up into hearts, spades, and diamonds. Or in this case, it could be like hearts and things that are not hearts. All right, anyway, I had given you an easy one and a hard one. The easy problem had 5 cards. Right away, you should go like this. 52, choose 5. Raise your hand if you knew that it was 52, choose 5 on the bottom. Okay, that's like the base of everything. You got to get that if there is a big group, the totals are always on the bottom here. And I'm choosing out 5 cards out of 52. All right? Now, for the top, it's the subgroups. And I said 5 cards are going to be hearts. How many hearts are there? 13, and I want to choose how many of them? 5. There we go. 13, choose 5. Now, do you have to do all the other cards? No, but you could. The other cards would be 39, and I'm choosing 0 of them. Now, why do I need to do? I don't need to do that, but it's smart to do that. It also sets you up really well for the other problem that I did. And I doubt many people would have had this right. First of all, how many had that one right? Raise your hand if you had that one right. That's about half the class. Okay, now let's try the hard one. I'm not going to erase everything. It's still 52 cards, right? And now instead of choosing 5, I'm choosing how many cards to be dealt? 7, so that's a 7. And there's still 13 hearts. I just want 5 of them to be hearts and 39 of them. Of the 39 remaining cards, I want 2. Because remember how this and this have to add up to that? And this and this are supposed to add up to that? Did anybody have that one right? Ooh, let's get there to the room. All right. Okay. So, do you get that I had 2 subgroups? Hearts and things that were not hearts. So really, even though I never said it, 5 have to be hearts and 2 have to be not hearts. So there was 2 subgroups there. This only needed 1 subgroup, hearts, because they're all 5 of them are going to be hearts, and we didn't need any of the other ones. All right, let's do something else, except this time not with cards. Let's show you how this can be applied to a lot of situations. Let's go with marbles. Let's say that there are 3 red marbles, 4 blue, and 1 yellow. I want to know, given you're going to grab 3 marbles, what's the probability you're going to get all 3 red ones? You randomly grab in there. You're not looking to try to grab red ones. You just randomly grab 3. What's the probability you're going to get 3 red ones? Well, you could make an awful tree. Really complicated. It would take you forever. Or you could do CC over C. Why? Because it's subgroups. A big group, like the deck of cards of 8 things, is subgrouped into reds, blues, and yellows. So anytime you see a big group divided into smaller groups, that's what you're looking for. CC over C. All right. So what's the probability that you get all 3 red ones? Well, I always like you to start on the bottom. This is B. Would you tell me how to start this problem from the bottom perspective? Yep. That is the total, and it goes there. There's 8 marbles, and you're choosing out. The big C is like choosing. 3. Good. That's where the total goes. And it's all the possibles. That is a lot. That is a big number, 8C3. It's a lot of possible combos that you could get. And what we want was, go ahead, of the 3 reds, you want to choose 3. Now, could you finish it for me? to it. 5 that are not red, choosing 0 of those. Now, some people like to divide it up and say, well, there's no such thing as not red. I want to do blue ones. 4 blue ones, choose 0, and 1 yellow one, choose 0. That works fine too, because that still adds up. Watch. 3, 4 is 7, plus 1 is 8, and then 3, 0, 0 makes 3. Okay. Raise your hand if you got that one set up right. Do you get how a deck of cards is similar to marbles in a jar? They're in subgroups. All right. Minnesota has 8 senators. No, I'm wrong. 2 senators and 8. What is it called when you're not in the Senate? You're in the House of Representatives. Just representatives? Okay. 8 reps. I'm going to call them 8 reps. And 2 senators. Let's say that I had a bill and that I was working on with one of those reps. And I really wanted to try to get it through. You try to get other people to sign on with you on your bill. Okay, like for instance, let's say that somebody's in a state where they don't pay for the ACT. Like up until now, everybody had to pay for their own ACT test. But the one that Minnetonka just did, and a lot of other schools just did, the state paid for it. It's kind of nice because, that saved the parents like $60. The test is not cheap. Okay, so let's say that I had a bill out there that said that if you were in a place where where nobody's paying for the ACT, you want the government to pay for your ACT test, and it could be the SAT instead of the ACT or whatever. The idea being, we want everybody in the United States to have the chance to go to college. Realistically, almost all colleges require the ACT, and therefore, maybe we're not going to pay for college for everybody. That's a big leap, very expensive. But maybe we should pay for everybody to be able to take the college entrance test if they want. Idea being, maybe some kids weren't going to take the test, and then they take the test and they're like, wow, I'm actually doing better than I thought. Maybe I should go to college. I encourage some people to go to college. Okay, so I have this bill, and I want to gather support. Let's say that I'm able to get 4 of these people, 4 of these 10 people, to sign on to my bill. What is the probability that it would be 2 senators and 2 reps? 4 people are signing on in support of my bill. What's the probability it would be 2 senators and 2 reps? First of all, I want to clarify, I am not suggesting this is actually something that I think is smart. In Minnesota, we actually already pay for it, and therefore it doesn't really help Minnesotans very much because we're already doing that out of the state's budget. But I am kind of jealous as a parent who's putting his kids through college right now. I wish that there was free college here like there is in some countries. There's downsides to it, but it's kind of nice right now for me if I didn't have to pay for my kids going through college. I think most parents would agree. I'd like to not have to pay for that, but the argument on the other side would be taxes would go up so much to pay for that I'd end up paying for it, maybe even more. I just pay my taxes. Sure. All right. So if you're ever in a weird mode where it won't get out of that mode, hit the on button again, and it does what's called break. Did it say break when you hit the on button? All right, try to turn it off. All right, I won't let you turn it off either. All right, then your only hope is to take the batteries out of the gun. hope to stop at that point. There is a backup battery too. We'll hope that it doesn't go to that. Okay. You're just going to have to borrow one of my calculators. All right. You should have said that this is a CC over C kind of question. And we have 10 people. We're choosing 4 of them. We were going to get support from 4 of them. The probability it would be 2 and 2 is out of the 8 reps you choose 2, and out of the 2 senators you choose 2. There you go. Raise your hand if you had that one right. Awesome. Pretty much everybody's getting these right now. That's good. Now let me make sure you get the difference between this and what we did yesterday. What we did yesterday was not probability. I was teaching you this ahead of time so that today would be easier for those that are gone, and there are quite a few that are gone. So yesterday's was just this. How is that not a probability? Because it's a total number of ways. Get how the probability is when you divide by possible? Well, this is just the total number of ways. This is how many different combinations of senators and reps there could be, and it's a big number. That's not a probability. Probabilities aren't big numbers. Probabilities are numbers between 0 and 1. Okay, so this is more about making a list of how many different ways you could do it. Let's talk about pizza for a minute. Let's say I have 5 kinds of pizza, 5 kinds of meats that you can put on the pizza, and 5 veggies, and 2 kinds of cheese. Now, in the old days, we would have probably just said, how many different pizzas can you make? And then you'd go 5 times 5 times 2, because you multiply choices. Now you got it more advanced. So now I can say, out of those 5 meats, you can choose 2 kinds of meat, 2 kinds of veggies, and 1 kind of cheese. Now, how many pizzas could you make? Notice this is not a probability question, so it's not CC over C. It's just the CC part. In this case, 3 Cs. I'll say it again. You can choose 2 meats, 2 veggies, and 1 cheese. I think in reality, a lot of pizzas have a couple kinds of cheese on it. It's called pizza cheese, which is like a mix of cheese. It's kind of pizza I've never had. It's pizza that just has cheddar cheese. I don't know if that would be tasty. Okay. Did you say 5 choosing 2? I like to do it that way with the C. It's kind of like the word choosing. 5 choosing 2 times 5 choosing 2 times 2 choosing 1. Raise your hand if you had that one right. Okay, good. And you just multiply your choices together. And that's how many there are. All right, now let's make it a little more complicated. Let's say that in the Best Buy warehouse, they have this huge number of TV sets. They've bought a whole bunch of them, expecting to sell them over the course of the next 6 months or whatever. So they have 1,000 of this certain kind of TV set. Okay. From their experience, usually a couple of them are bad, like they don't quite work right. People are going to get them home, and they're going to be something squirrely about it. Okay. There's 1,000 total, of which 2 of them are defective. Then, some guy walks into the store and buys 2 TVs. What's the probability? He's going to get 1 that works and 1 that is defective. It's the same problem as all those other subgroups. It's just you have 2 subgroups. TVs that work, TVs that don't work. Just like clubs and spades, just like reps and senators. Okay? Don't let this get you all twisted up. It's the same kind of problem. It does fool people every year. People struggle with this. I'm going to say it again. There was 1,000 TV sets, of which 2 are defective. 2 of these are defective. I didn't say there was 1,000 working ones. I said there was 1,000 TVs. 2 of them are defective. And the probability then is you're going to get 1 of each. You buy two TVs and you get one works and one doesn't. Okay, CC over C. CC over C. These are my subgroups on the top. B on the bottom. Choosing how many? Good. On the top. And what was that? There were two defectives. Okay, and you had two of them and you chose one, yes. 98. Choose one. Very good. So you got one normal and one defective. Now, how could I check and see if I set this up right? Do you remember that? I'm telling you, this is really smart deal. Add that, add up to that, and that, add up to that. You'll prevent very common mistakes. You'll stop yourself from making mistakes, because if those don't match up, something's wrong. All right. How many of you set it up right? Good. Okay, one more. Again, I'm going to try to make this like something you can relate to here. Subgroups within this classroom. We're going to go with... Everybody has a backpack, so that's not going to work. Okay, people that are wearing a watch versus people that are not. Who in here has a watch on? Only one person? That's too small of a subgroup. All right. Oh, two people. Okay, that can work. I can tell you the total number of people in here. 2, 4, 6, 8, 10, 12, 14, 16, 18. Man, a lot of people today. Including me, 19 people. There's 19 people in here. And 2 have a watch. The principal randomly comes in and takes 2 humans out into the hallway. What's the probability he's going to get both people who wear watches? Anytime you think it's a big group divided into subgroups, it's a perfect time to use CC over C. Mr. M, tell me what to write for the bottom. Okay. And then for the top, 17, and what were those? No watch people. And you're choosing 0 of those, and then? And those are the with watch people. Okay. Here's your hand. You have to add that one right. Okay, everybody's here today is following this really well. So, okay, that's CC over C thing. Now, I'm going to go through a quick review of the stuff you've done before, because your your test on probability reviews all 3 parts. Okay, and you guys did really well in the first 2 parts, so that actually, it may sound like a scary thing, but it's actually a good thing, because it includes problems you're already really good at, you got good scores on. You've got to remember how to do them, right? So let's throw in a few, let's do a Venn diagram question. Nerf, what's that game where Assassins, right? Nerf Assassins. So these are kids that were pulled at the high school. These are kids that were a Nerf assassin. These are kids that had a car. And these are kids that like unicorns. Okay, and these are the losers who don't have any of those things. Okay, yes. Good question. And we're going to say the kid has access to a car. Like, they get to drive their parents' car, or it's their car. We don't really care. So, I suppose we could say license to drive a car. Okay, I'll say car license. Driver's license, probably. Start with that. I probably would have chosen the word driver's. All right, and obviously there's going to be lots of people. blank over there. I was just kidding. Not like left out or whatever. Not many of you would willingly admit that you like unicorns. Okay, so anyway, maybe when you were third grade, a lot of guesses. I'm going to give you some numbers here, and I want you to fill them in the right spots. People that like all three, there were 10. Either they have them or they like them. People that qualify with all three, there were 10 of them. You should have wrote that right there. Okay, now, people that are licensed to drive a car and still like unicorns is 10. See if I fooled anybody there. Did you put in 0 right there? Because you should have. Because when I said licensed to drive and like unicorns, that was both areas was 10, and we already had 10, so the other number must have been 0. Okay, now we're going to do something like that again. That's where people make the mistakes usually. Unicorn liker and Nerf assassins. 12. Nerf assassin and unicorns. I said and. 12. Again, the mistake people make is, oh, okay, that's the area he's talking about. No. The area I'm talking about is there. The total is 12, therefore 2. All right. That's one thing I wanted to point out. Next is I'm filling in numbers here to make it go quick. 1, 3, 2, and let's say 7 and 4. Okay. Now we can get a grand total here. 3, 4, 5, 6, 16, 18, 25, 29. 29 grand total. I want an answer as a fraction now, so I don't have to go grab a calculator. Given that I know the person I'm going to pick has to have a car license. Given that they have a car license, what's the probability that they like unicorns? Given they have a license to drive a car, what's the probability that they like unicorns? When I said given, P, A in the back, what did you change? The top or the bottom? Good. Given changes the bottom. And what is the bottom then in this case? All right, it's 15 because people who like car licenses are in there, and only those numbers can be used. That's a really key point. Some people then get to the next part, which is unicorns, and they go, oh, so add up all the unicorns. 17, 18, 19. No. What did you use? Good. And I put that in the wrong spot. 10 out of 15 then. The total here goes on the bottom. Raise your hand if you had 10 out of 15. Okay, good. I'm going to give you a really complicated one now, see if you can handle it. Given that the person did not play Nerf Assassin, what's the probability they did not have a car? Given not a Nerf Assassin, probability of not a car. Miss VH, walk me through this one. Well, since I can do this, it's much easier for me to do this than you. Can I just scribble those out? All right. What's left is what you added up, right? And they went where? Did you say 13? Good. And then finish it for me, Mr. H. How? Where? All right. So they do not have a car. And which are the ones that do not have a car? Which two numbers? All right. These are the two that do not have a car. That's what I want. So we'll put them together. The 7 and 4 makes 11. 11 out of 13. Raise your hand if you had that one right. Nice. It's the hardest to find. I can't stump you on those. So what else is left? Well, there were expected values. So if I said warranty on the smartboard, this is a real thing. The smartboards run around $3,000. Let's say, and I know they do, offer a warranty on the smartboard. I don't know what the price tag is, but let's imagine for a moment that the price tag is $200 for the warranty. $3,000 board, $200 warranty. Then if these things fail 10% of the time, then I want to know, what would the school district's expected value be for buying the warranty? You do have to figure in the cost of the warranty. Yes, sir. Good question. In the real world, you probably get some, basically a repaired board, which you're right, makes a difference. For our example, it's going to be a money-back deal. They take the board back and give you your money back if it breaks. They don't give you the warranty money back, but they give you the cost of the board. All right. So these are always P times A. If you didn't think of that, I am very sad. P times A and then add. That's the key to these problems. Probability, work, 90%. Break, 10%. Okay, the 90% that work, you get nothing. The 10% that break, you get all your money back, $3,000. I know some teachers do the subtracting right there. I don't like to. I like to do my P times the A without factoring in the cost of the warranty until the end. I think it's way easier. 0 times 90 comes out to 0. That's one of the things that's nice about doing it that way. And then I multiply this and I get 300. And then the cost of the warranty needs to be factored in after I add these up. These add up to 300. 0 plus 300 adds up to 300. That's what the warranty's worth. How much did I pay? Subtract off 200. Am I still ahead? Yeah, I'm still ahead by 100. That was a good deal. Your expected value, or the school district who bought it, their expected value is $100. Now really though, do you expect to get the expected value? Is the school district expecting, I'm going to get $100? No. But it's a way for them to say, okay, this is probably a good value for us. I'm willing to spend the money on it because it's a good deal. Because the reality is, 90% of the time, they won't use it, right? So they should actually expect that they aren't going to use the warranty. 90% chance they won't. But if they do, it pays off big enough that the expected value is $100. So if the school's expected value is 100, what's the expected value of the company that sold it? Minus 100. The thing is, in the real world, the company that sold it is giving you a smartboard that they say is worth $3,000, but they might have only paid $500 to build it. You know what I mean? They have a lot of profit built into that, so it's cheaper for them to give you a $3,000 smartboard than to give you cash. So in the real world, a lot of times, these aren't cash-back deals. These are, I'll fix your smartboard for you, or I'll give you a new smartboard, because that's cheap for the company that makes it. You know what I mean? It's like Apple giving you a new phone. Does it really cost them $800 price tag of a phone? No, they just have to pay for the parts. So, all right, that's a warranty type question or expected value question. And the last kind, the kind you had to test on very first, and that was just things like blanks. Let me give you an example. There's a crazy rich guy who lives on an island, and he decides, I want license plates for all the golf carts that I have on my island. And he's going to have a letter and a number, like A7 could be a license plate for one of the golf carts. So it just makes it easier for him to describe which one of the. He's got lots of golf carts. It's a Caribbean island. It's never like snows down there. You can always drive the electric golf carts around. That'd be pretty fun. So he's got a fleet of them. He asks you, okay, I'm deathly afraid of the letter F, and I really don't like the number 4 because if the Chinese don't like it, I don't. So he wants to know how many different license plates can I have? I'd use blanks. There's 2 blanks. The first blank, number or a letter, it really depends on which you pick. Because I think I said a letter and then a number, but it doesn't really matter because if you're just multiplying 2 numbers, if you reverse them, it won't matter. The letters part is normally 26, doesn't want F's on there, so 25 times normally 10 digits. A lot of people get that confused. It's not 9, it's 10-digit choices, but we're taking off 1 because he doesn't like 4, so it's 9. 25 times 9 is your 10. All right, here's a little more complicated one. There's 5 digits. No, I'm going to make it 5 places. This is the rich billionaire guy again, and he's taking a picture. And he's got 10 people with him on the island visiting. But he thinks that pictures with 10 people in them are too clunky, and he thinks that 5 is much more elegant. So he wants to take pictures. If he's got 10 people, but only 5 can stand in line at a time, and he's got to be in the middle because it's his island and he wants the picture with all of his friends. Okay, he's going to be in the middle of these pictures. How many different pictures would you have to take if order matters? In other words, being in front is different than being to the left is different than being to the right. He's got to be in the middle. Okay, if he's got to be in the middle, how many choices do I have for that spot? 1. And then if he's got 10 friends, did I say there were 10 people total or 10 friends? Which one did you guys use? Did you assume 10 people total or did you assume 10 friends? I think I said 10 friends. So if he's got 10 friends, then this choice is 10 people could be there. But they can't repeat people, right? 9 people there, 8 people there, 7 people there. Those are the choices. How many choices we had for all those ones? 10 times 9 times 1 times 8 times 7. A little bit clunky, but I strongly recommend on ones like this that you not try to do CC over C. There's the right tool for the job. You can use a drill to cut a board in half, but it is incredibly clunky and slow. Okay, that's sort of like you can use a tree diagram to answer this question, but oh my gosh, it would take you forever. I don't want to do that. At the same time, you could probably use blanks the quickest if blanks apply. Like if you can use blanks, it's a great method. So it's sort of like your tools in your tool bag thing. And you might pull out the blanks method for some problems, and you pull out the CC over C for other problems. And there's one more powerful tool that we haven't showed you yet. It's called binomial. And the binomial would answer a question like this that was previewed for you. Let's say Mac is a free throw shooter. He's pretty good at it. He practices a lot. Say he's a 95% free throw shooter. Okay. Then what's the probability that he would make 3 out of 4 shots at the end of the game? It's kind of a complicated question. There's this thing called the binomial theorem that answers it really quick and easy if you know how to do it. And I'll show you how that works. I'll give you a quick preview of it and see if it gets you. Maybe some of you are fast enough to catch it. 98% free throw shooter. Then you have to account for the ones that he might miss also. He's a 02% free throw misser, right? I want him to make 3 out of 4. So that's 3 makes. That's 1 miss. We want him to miss 1 to make what we said come true. 3 makes, 1 miss. And there's one more piece. You have to do a C thing in front. This tells me how many different ways that could happen. This is three free throws made and 1 missed, but you could have missed the first one and then made the other 3. You could have made the first one and then missed the second one and then made the other 2. So there's a lot of combinations, right? So you say there were 4 shots, and we wanted him to make 3. So 4C3, 0.98 to the third, 0.02 to the first. That's the binomial theorem. That's how that works anyway. That's a little preview for what I'm teaching on Monday. Okay, that's all I have for you for today. It's a pretty thorough review of what we've been doing so far, and it's not everything, but a lot of it. And then you come back to binomial, and then a review, and then you got your test middle of the week next week. That's all I have for the video for today.